This is an initiative that we started last year to put together sort of a cross-industry user group. Not exactly like the top 500. The top 500 we're fans of and it will endure, but the top 500 is a ranking of supercomputing prowess at the top of the list. The problem with it is that it's not a good representation of the industry overall. The HPC 500 is meant to be a more balanced look at HPC leadership worldwide if we put together a demographically balanced group of all of the different applications, the different user types, the different geographies, different budget sizes up and down. And we're offering a lot of benefits to end user members who will sign up to be part of this group. You get free access to our research. We're having regular member calls. As you saw me updating my slide, we had the first one on April 4th. We're having another one on July 10th to start talking about different users' experiences with programming models of different architectures. We're actually approaching 200 end user organizations signed up now, and we'll continue adding to that over time. Another major change for us early this year is that we hired Michael Feldman onto our analyst team at Intersect360 Research. Many of you will recognize the name. He was until recently the editor of HPC Wire. He's now left the journalist side and joined us as an analyst. We're just absolutely thrilled to have him on board our team as an analyst. I've been working with him a long time. He was my longtime podcast partner on HPC Wire Soundbite. I now continue doing that podcast together with Nicole Hemshoff, who's now the editor of HPC Wire. For our clients, we've started publishing reports in an additional way where we always do the 20-30 page research reports, which are nice and meaty and chewy and have our analysis. We're now also publishing along with that more of an overview in PowerPoint format, which is a little more digestible, and we found that our clients like that as a faster way to get through all of our research, and it also lets us publish more things in slide format that we didn't have the bandwidth to do the long written reports. And then finally, we're putting out a regular newsletter now. Many of you are already on that list, but if you want to stay up to date on what new research, new articles, what new podcasts are out, you can sign up for that at intersect360.com. Then I also brought these up here to remind me that, of course, as always, we put out a new edition of HPC trivia cards, which we do for ISC and SC every year. So these are hot off the press, and if you'd like a set of new trivia cards, see me. Okay, that's the commercial. Topics for discussion. We did just put out a new HPC forecast. I'll give some of the highlights for that based on some shifts that we've seen in budget allocations from our budget map survey every year. From our site census data, we're really tracking a lot that's going on the processor side and what implications it has throughout the industry. We're redoing our big data study this year, which remains a major trend, and then of course we have to get cloud into it, and both of those last topics will be discussed in more detail at the ISC Cloud and ISC Big Data conferences this fall. Okay, total worldwide HPC revenue. This is just the top level. First of all, the chart comparing 2012 to 2011. We did see growth of about 7% year on year from 2011 to 2012, but a lot of that came in the storage bucket, and that is largely a mirage. There was some real storage growth, but not the $1 billion in storage growth had to do with the flooding in Thailand in late 2011, which will continue to have implications all the way through reporting the change from 2012 to 2013. Many of you will remember that Southeast Asia had rampant flooding in the second half of 2011. And as that ate through the inventory of spinning disk for a lot of the storage providers, by the time we got into the fourth calendar quarter, what we saw, not for every storage provider, but for many of them, we saw a lot of deals get delayed, at least in revenue recognition, from the fourth quarter of 2011, into the first quarter of 2012. And since it happened over a calendar year boundary, it had the effect of dropping a few months of revenue that you would have seen in 2011 into 2012. And therefore, 2011 wound up being abnormally low, and 2012 winds up being abnormally high. And what you'll see is when we go to 2013, it'll probably fall down again a little bit, because you go from having a year that had 14 or 15 months worth of revenue in it down to one that has only 12. So it's an artificial thing. It nevertheless actually did happen in the market, and we have to track it. The interesting thing about it was when we went to put together our market model and forecast, we had it in our notes that we had to be wary of that and make sure we modeled it in. A lot of the market sizing and forecasting that we do is based on our end user research, where we ask end users how much did you spend on things, and we take those averages and build them into our total market models. The remarkable thing that happens is when your methodology sort of takes care of it for you. And what we found was end users actually reported to us that they spent less on storage in 2011 and more in 2012, and the model actually kind of balanced itself a little bit. What you see then is slightly lower than normal growth rates in everything else. The servers, the services, the software, networks were higher, but these numbers kind of in the 4% range are a little lower than we would normally see. That is because the public sector spending is still relatively slow worldwide. The government academic spending is still below the norms that we would tend to see, particularly in US and Canada and in Europe. Europe continues to see weakness in the public sector, especially. Commercial seems to be fine. All this growth that you see is currently driven by the commercial segment. Going out to the 5-year forecast, we do continue to see healthy growth. The storage stuff will balance itself out. Storage, software are some of the high growth segments in all of this. 2012, we're at about $28 billion for a worldwide market right now. This is inclusive of both what we call high-performance technical computing, which is science and engineering types of applications, as well as what we call high-performance business computing, which is the use of HPC technologies for non-scientific business applications. Finance is the biggest segment, media and entertainment, the servers behind online games, ultra-scale internet, retail, transportation, those vertical markets. Okay, budget map. This is from our most recent HPC budget map survey, and I mentioned that this data flows a lot into our total market models. We did again see some interesting things happen here. The budget map survey asks end users at the start, first of all, what band their budget is in, just in ranges. They don't have to give us the exact amount down to the dollar, but about how much they're spending, whether they're expecting it to grow or shrink over the next 2 years, and then dividing it into primary categories. What percent of your HPC budget gets consumed by hardware, by software, by facilities, by staffing? Is this a laser pointer? It is. Great. Services, cloud computing, and other stuff. And we've been doing this survey annually for the last 5 years. This is the survey year. You'll notice there's not a 2009. It's not really that we skipped a year. It's that we reordered where in the calendar some of our surveys fall, and it went from being late in 2008 to being early in 2010. So it's essentially 5 years of annual data. The most interesting thing that happens in this chart is we've been tracking this trend where the proportion of spending that went to hardware in general had been falling every year. And it looked like that was a continuing trend until all of a sudden it jumped back up to the highest level we've seen it in our most recent survey, to the point where we really scrutinized that to see was it an anomaly in the data. And it doesn't appear to be, because no matter which way we segment that, if we look at academic, if we look at government, commercial, big organizations, small organizations, all the different geographies, it happens across all of those different segments. So it really doesn't appear that that it's just a sampling error. This really does look like it's a trend that all of a sudden hardware snapped back. And our analysis of that is that what we had here was kind of a recessionary period in 2010 and 2011 where a lot of capital spending was getting deferred. And then in 2012, we start seeing a catch-up, if you will, where there are more users who started bringing those updates in and hardware spending snaps back. In the 2012 survey then, that takes a bite out of a lot of other things. Facilities had been climbing and then all of a sudden falls as a percentage in 2012. Now what this doesn't show, however, is this is showing for people who are spending money on this out of their budget, what percent is going to, for example, facilities. Another thing that's in this survey is the ability to mark any category or item within a category as not in budget, which means someone else pays for it. And that happens in the facilities category more often than anywhere else. However, it has been a trend that that percentage has been falling every year in facilities, which is to say that more and more users every year have to account for facilities as part of their HPC budget, and that trend has been continuing, that power and cooling costs, for example, get tagged as part of the HPC budget more often every year. Another thing I want to talk about on this chart is cloud. Cloud is part of the market. It remains part of the market. Utility computing has been part of this industry for decades. It's not new. Cloud is not this magical thing that all of a sudden shows up and everyone starts spending all of their money on it. It is about 3% of HPC budgets and largely flat year on year. There's a lot of utility computing that we're now calling cloud that we didn't call cloud before. As an example, maybe an oil and gas company sends their data sets to Schlumberger on the way in, and Schlumberger does a lot of the analysis, and then you access that remotely. Schlumberger has had that as part of their business model for a long time. It's just now you call that cloud computing. And that's part of the market. This implies that if you look at the proportion of spending that goes to servers, which is a little more than half of the hardware budget. So servers are about 24% of total budget spending overall. Cloud computing is about 2.5% of spending overall. That implies a 10-to-1 ratio of for every 10 euros that got spent on a server, there's a euro that gets spent in public cloud somewhere. That implies about $1 billion of HPC public cloud revenue in a given year, which is not nothing, but then that's divided between SaaS and raw cycles and all the other things that go into that. So from our HPC user site census survey, this is the other major anchor survey that we run every year. It's a wonderfully simple, hideously complex survey that asks the basic question, can you please tell us everything that you have installed and how long you've had it? So we're looking at servers and storage and processors and operating systems, middleware, applications, the works. We run this survey every year. We're on the 6th year of that one as well. Primary challenges that are coming up for users all have to do with these changes that we're seeing in the processor architectures that are now flooding into the market. Whether you're staying on just basic x86 and coping with multi-core, or you're building in different types of accelerators or looking at other types of architectures, there are impacts on parallelism, on system administration, on job management, no matter which of these ways that you go. And these are some of the notes that we brought right out of the site census report in terms of what users tell us they're coping with in the market. This trend here is one of the major ones that really has implications for HPC in the industry. I've withheld the last year of data from this, but just take my word for it, the trend has been continuing. What you see here on the bottom is the amount of memory per core that people configure in an HPC system has stayed relatively constant. It's actually grown a little bit over the last 5 years. This is sorted by what year the system was installed. But then as you add more and more cores into a processor and potentially more processors into a node, the amount of memory then per processor keeps doubling and redoubling, and the amount of memory per node increases exponentially to where systems that were installed 2011 into 2012 at an average of 68 gigabytes configured per node, and as I said, that number continues to increase as you go into 2012. This has some really practical implications in terms of what that means for configuring a system. You have to start worrying about the cost of that memory, how much power all of that memory draws, whether you've got the memory bandwidth to handle that in your system, etc. Accelerators we do see as a major part of the market. We actually have a new accelerator report that comes out. What we keep seeing is actually an increase in the number of end users who are at least trying accelerators. Now this data looks at primary systems installed, and among primary systems installed we're seeing it up, it's actually now past 30% of systems have accelerators at least installed. That wasn't my phone didn't go. Someone got a message. But the use cases, the actual implementations of how many accelerators a given application uses remains low. Now this is looking at all types of accelerators, including Intel Xeon Phi and accelerated x86. We're going to continue to see accelerators adopted into the market, but even today in 2013, we're seeing the majority of the end user space in a trial, wait and see, evaluation sort of period. I'm getting these different architectures in. I'm trying to figure out which ones are going to suit my applications well. We don't see a lot of really wide-scale, full-on deployments yet. Even among the supercomputers that have them configured, whether you're talking about something like a Stampede or a Milky Way 2 with Xeon Phi, or the number of them that have GPUs, we're still figuring out how we're going to efficiently use those accelerators at scale on a wide variety of applications. So some of the challenges of these architecture trends, I'm trying to catch us up here, Brian. I mentioned power consumption. All of these extra cores, extra memory take up a lot of power. They have a lot of direct cost implementation, and they have direct implication on how are we going to approach parallelism throughout this decade. Is MPI adequate? Do we need, I hear people talking about MPI plus, or do we need something else? Do we need an overlay layer like Swarm or something else that'll take care of the parallelism? There are architectural considerations, as we were just discussing in the last two presentations, looking at different models of architectures to handle parallelism differently at scale. The languages, the programming models, especially for accelerated solutions. Are we going to be using Fortran and MPI for these codes and these architectures as we go through petascale and towards exascale? System efficiency is a major topic of conversation within the top 500 list, to say, sure, you can hit a petaflop on this, but can you hit a petaflop on that, right? Not that I need to get straight here, though, that I like top 500 and the fact that we have this out here. It's nice to have something that people keep striving for. I think it gives the popular press a nice way to relate to a supercomputer. But among those of us in this room, you need to have an awareness of what is this supercomputer for. I also like the idea that Blue Waters would say, our system is not well configured for top 500 and we're not going to measure it that way. I think a supercomputer site needs to have that kind of latitude to be able to say, this is not what this computer is for, don't judge it that way. Personnel is an often underappreciated challenge that goes along with all of this. When you go back 15, 20 years and a supercomputer was a relatively self-contained device, what it meant to be a sysadmin meant a lot different to what it meant to be a sysadmin in the cluster world, right? You go from someone who really needed to master the operating system at what it meant to scale an operating system up to however many nodes in a shared memory environment often, or a vector environment, to a distributed solution where now you have to worry about the middleware stack and job management and scheduling. What it meant to be a system administrator really changed over the course of about 10 years, and what it meant to be a system or an application programmer really changed over that time, to where you really needed a different understanding of parallelism. And as we go forward into these new models of parallelism, we really foresee this changing again, where you can still have that same title of a system administrator or an application programmer, but the implication of what your area of expertise is really changes again in terms of what skills you need to master in order to maintain a productive system at this level of scale. And I think we need to be very aware of that as an industry, that you're asking for a different skill set out of what's ostensibly the same person, or at least the same title. Just a few notes on big data, because I think it is still a pervasive trend. Diving into it from the standpoint of why we look at technical computing as being different from enterprise computing to begin with. HPC versus enterprise, they both use the phrase mission critical, which amuses me because they mean different things in the different contexts. HPC, one of the hallmarks of it is that you tend to see it deployed to solve whatever it is that the top line goal of that organization is, whether it's finding the oil or designing the car or curing the disease or maintaining the risk or spying on people if you're the CIA, right? Toyota buys a lot of computers for a lot of different things. The ones it uses to design cars, trucks, and minivans are HPC, etc. Whereas in enterprise computing, what you tend to see is it's mission critical in the sense of I'm keeping my business running. If my website goes down, I can count by the minute how much money I'm losing. But I'm not in business for the purpose of running a website. The website is keeping my business running. Run the website, manage the ERP system, the payroll database, the email system. All that other stuff is enterprise computing. And the reason we track them differently is because they have different buying profiles. Technical computing tends to be driven year after year by different metrics of price performance. I want to maximize how much power I can get out of this system according to my capital, personnel, and facilities budgets. Whereas enterprise computing tends to be driven year on year by reliability, availability, serviceability. My payroll database is working. I have very little incentive to rip it out and try to replace it with something that runs 4% faster. My partner, Chris Willard, is fond of saying the watchword in HPC is, once you solve the problem, it's no longer interesting. You don't need to design the same bridge twice. Whereas in enterprise computing, the watchword is, once you solve the problem, for heaven's sakes, please don't touch it, like ever again. Right? It's working, leave it alone. And therefore, in HPC, you tend to have relatively faster adoption of new technologies, new approaches, new algorithms. And in enterprise computing, it tends to be relatively slower compared to HPC. Where this gets fun is in big data. I'm not going to get into whole definitions of big data other than to say that it's not a specific technology, right? You don't go out and buy a big data. I think when people ask me as an analyst, what's the tough one is, what's the size of the big data market? I get asked this all the time. My problem with it is I don't know what to count, right? What specifically am I meant to count when you ask me the size of the big data market? If I have a server that I already had that starts running analytics on it sometimes, what am I counting? Do I amortize the whole cost of that server into the big data market, or only the new software that I bought, or where did the data come from? I'm not clear on what revenue to allocate there. So I reinterpret the question, because if someone like, I'll pick on Bjorn sitting right here, HDS comes and asks me what's the size of the big data market, what he really means is what's my ability to sell the stuff I have to new sets of users because of that. Now that I can answer, because for HPC-oriented companies, there's a tremendous opportunity to sell high-performance technologies into new areas because of these trends where what you really see about big data is this collection of trends where the growth, the rapid growth in the amount and the availability of more data and more types of data is freaking out my organizational ability to achieve or maintain some kind of competitive advantage based on that data. That, to me, is what we're all crying about in a nutshell. So there's all different types of challenges. The only thing I'll say here that's a fun one is this bottom one, is that big data does have this kind of leap of faith aura about it. Like, my neighbor dug in his backyard and found treasure. I want to dig in my backyard and find treasure, right? There's this presumption of if data, then value. I don't really know what I'm looking for, other than I have access to all this data and I think it might be valuable. Can you please tell me, right? So let's go looking for it. And it has all kinds of different challenges. You might be dealing with, you know, the challenge inherent in large files, like I have a file that's 100 terabytes that I need to ingest, is very different from the challenge of I have 100 million inodes. And you have to keep in mind that these different dimensions of challenge all have different architectural implications. And what you're trying to do is scale this up. It has, even if you're a non-HPC user, implications in parallel file systems, I/O interconnects, operating systems, cloud. How do I scale to take care of this in my enterprise data structure? And that's where these high-performance computing technologies tend to come in. We did a major survey on this, and we're in the middle of redoing it again now. And we partnered with Dan Olds of Gabriel Consulting Group, who some of you might know, so that we can survey not only our traditional technical database, our HPC-oriented database, but also a non-HPC-oriented enterprise database. And part of the analysis is to do a compare and contrast on that. What are the similarities, the differences, the opportunities, et cetera. 3 main points to take away from the survey that we did. One is that this is way broader than Hadoop. If you take my premise of this is the set of trends and the problem or challenge, the challenge that we're trying to go after, Hadoop is part of it, and it's about, or it was at that time, 18 months ago, about 15% of big data workloads. I'm going to 1.5. We'll see in the next survey how much that's grown. But the point is that it's the biggest application, the fastest growing, but it's in a sense the biggest brownie in the pan, right? And as soon as you said, well, my big data strategy is Hadoop, you left out 85% of people who said they're doing big data, but they're not doing Hadoop, right? So what's in the rest of that brownie pan? Well, half of applications and algorithms that are being deployed for big data are internal. 50% are people who are running their own internal applications and algorithms to scale in-house data. If you think about that as more than 3 times the Hadoop opportunity, you know, why aren't more people talking about that aspect of big data? We can help you scale your own in-house stuff. That's a big part. There's a huge amount of money being spent on it. And the third point here is the important one, is that performance matters in this space. There's a different chart I took out. But if you look at what are the key pain points here, the interesting thing that happened is that both enterprise and technical respondents flag I/O scalability as the top pain point. Now, this is remarkable because even in the enterprise group, the business group, you had a performance metric trump the reliability, availability, serviceability stuff as the key evaluation criterion for looking at big data. And the reason that happens is presumably because of our definition of big data to begin with. If I wasn't having a problem scaling it, it didn't meet the hurdle of what we call big data to begin with, right? The whole assumption is that I need something different, and that's where the opportunity for HPC technologies comes in, whether you're talking about a better interconnect or a better file system or the ability to scale your server infrastructure. Now, cloud has not been a huge part of this. I had some longer, colorful analogies that I took the slide out, but the one thing I like to say here that I will go into is that the reason we don't see cloud really hitting either HPC or big data in a huge way is because there are so many barriers. The data movement, the security are the top of a long list of barriers that prevent people from moving HPC and big data applications or workloads into the cloud. And the metaphor that I like to use for this, and apologies to anyone who's already heard it, is let's say I woke up this morning and I decided that after a thorough analysis of all of the benefits involved, that I would really like to be the Queen of France. Right? I've decided that this is I get to eat all these great foods, I get to wear pretty dresses, I can behead anybody I don't like. The benefits are great, I would like to be the Queen of France, sign me up. Well, Addison, you tell me you can't be the Queen of France. Why not? I put it to you, why not? Why can't I be the Queen of France? If I handed out a survey, right, tell me, why not?
You're not French.
Not French. I would run the survey in this audience. In fact, I've done this with live audiences. The number 1 and number 2 answers I get back are not French, and anyone care to guess the other major reason I get? Not a woman. Not a woman. Not a woman and not French come back as the number 1 and number 2 answers. Gosh, I'm bummed out. I really wanted to be the Queen of France, and I go away all upset. But I wanted it so badly, I come back to you 2 years later, and I say, guess what? I wanted to be the Queen of France so badly, I've obtained my French citizenship and had gender reassignment surgery. I would like to be the Queen of France now.
No monarchy in France anymore.
What? There's not a monarchy in France, and I'm not of royal birth. Well, gosh darn it, why didn't you list those among my top 2 barriers to begin with? Right? This is my point, that looking at the top 2 barriers can be a bit misleading sometimes if what you really have are a whole bucket of barriers, and any one of them is significant enough to stop you. So, yeah, okay, the data movement, the security come up as the top ones here, but what if my software isn't compatible with it, or the cloud provider doesn't have a capability that I need, or the results aren't lining up with what I want, or any of these things? All of these things are barriers that might prevent you from moving an HPC or big data application into the cloud. Final thing I'll say is, you get into this, well, cloud is a major IT initiative and big data is a major IT initiative. Therefore, big data in the cloud should be a big IT initiative. And there's kind of a problem with that for all of the answers that I just went into, okay? All right, so conclusions. There are absolutely opportunities for breakthrough performance here. The new technologies coming in can deliver an awful lot of flops, can deliver theoretically a ton of parallelism, but there are implications about how are we going to do this efficiently at scale. There are also tremendous opportunities in the market with cloud and with the commoditization of various technologies to expand HPC into more user areas. But there's a question of what the access model is for that. It's not always as simple as just saying, hey, run it on Amazon, right? That might be hard. Getting people creating their first digital models might be hard. All that said, I think big data is really the big near-term opportunity for selling HPC technologies, bigger so than the whole missing middle area in manufacturing. Missing middle will come along, but it's slower. If you're looking for which one is a huge money revenue opportunity for HPC technologies right now, it's big data. Okay, that's kind of an overview of stuff for 2013. Try to get a year's worth of research into half an hour, but happy to take any questions. Thank you.